So this talk is called MySQL Security More Than Just ACLs. How many here are actually using MySQL and want more security tips? Most of you? Okay, great. If you do, actually, I do a weekly podcast about MySQL. I've got some CDs down there. It's free to download and you can just get it, but I figured sometimes a physical reminder is better. So this talk is MySQL Security More Than Just ACLs. I'm Shiri Cabral. I am a senior database admin / architect at Mozilla, so that it's DBA, but the A has two meanings. You can tweet me, you can find my blog, blah, 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 all that kind of stuff. That's all the intro I'm going to do. So let's talk about security. And let's talk about security in general first, right? So in general, when you talk about security for any application, doesn't matter if it's MySQL or Apache or your operating system, anything that you have security for, you have to worry about a few things. One, you have to worry about patching. MySQL, at least Oracle, puts out a new release each month. And Percona and MariaDB usually do follow suit. So every month there's a new release, and this could fix security issues. It could fix crashing issues. So it's important to be up to date. You don't necessarily need to patch it every single month, but you definitely need to be up to date on what's a security hole and what's not, and what's patched. MySQL has a new major release every couple of years. So MySQL 5.1 was released in 2008. MySQL 5.5 was released in December of 2010, so just about 2 years ago, because it was like January 11, December 10. And they're just about to release 5.6 as a GA release. So you want to make sure that you're at least on the most current stable version. Like right now you should be on 5.5. That's going to fix a lot of security holes and things like that. So you want to make sure that in general you're up to date. It doesn't have to be to the minute. Preventing access. If you have a web server, you probably want most of the world to see your content on the web server. But if you have a database server, you probably only want the application to be able to get to the database server. You don't need everybody from the outside world to get to the database server, unless, of course, that's the service you're providing. And if people do get in, you want to be able to prevent meaningful information gathering. Maybe they can get some information, but maybe it's not meaningful, right? If you don't store the credit card of somebody, they can't steal. Nobody can steal the credit card, right? So if you only store the last 4 digits, that's all the information they can get. So we talk about access. What kind of access is there? Well, there's network access, direct database access, and access to backups. So when we talk about access, most people think, well, I have a firewall in place and they can't get to my database. They can't actually just directly get to my database, so that's not a problem. But where are you replicating to? Where are your backups? How do you take them? Do you take them over network? Are you streaming over Netcat because that's faster? Are you doing a MySQL dump over SSH, or maybe not over SSH? You can actually sniff out packets in MySQL where you sniff it with TCP dump. You can actually do that and see MySQL queries going back and forth in the clear. So you have to really be careful about that. Now this hasn't been a problem for a while, but now with the advent of the cloud being so popular, think about this. If you're in the cloud and you're using one of these cloud technologies, let's say Amazon, because that's what most people are using, and you're replicating from one machine to another, who can see that network traffic? Now at TCP dump, you need to be root to see anything. So if you have an Amazon AWS machine and I have an Amazon AWS machine, I can go on my Amazon AWS machine where I'm root, do a TCP dump, and see all of the MySQL traffic going back and forth that's flying around for everyone who's not using a secure MySQL connection. It's a lot of fun. So here is the TCP dump flags you need to use. TCP dump -L. Now this is assuming that you're using the standard MySQL port of 3306. And you're piping that all into strings, and I've tried it and it works, and it's the poor man's query profiler. It's a lot of fun. So anyone who's on your network can see your traffic unless you're using an encrypted connection into MySQL. And we'll talk about that in a little bit, about how to do that. So the network is a huge access point, again, especially with the advent of the cloud. Who is on your network? You might have an internal company network and it's a private VLAN. Great, no problem. The access point of the operating system, right? Obviously, if people are logging into your operating system, that could be a problem. Who has the ability to log in? Do developers have the ability to log in? Are these people who are supposed to be able to see the data or not? What about logs? What about backups? Now, part of backups is the logs. So you have binary logs, and those are your incremental change logs for your data. So you want to be careful about where those are stored as well. Because if somebody can see you did an insert into a table, it's credit cards, well, they can see that one insert, they then have that credit card. So a little bit about encryption. When you do encryption in MySQL, it's per client. Do you have a question?
Just an OCD comment for you.
Sure.
Command's wrong.
What's wrong?
Specific command is wrong. You've got a space missing.
Space missing where?
Minus W. The argument to minus W is the hyphen. It should be minus W hyphen to say write to the standard out, and then get rid of the minus on the next line.
Oh, that was a problem because of what was happening before with the thing. I just put a new line. There you go. That's what it should look like. And actually, if you downloaded the slides off the internet, that's what it says, because it's actually a long line. Thank you for correcting that. So, encryption in MySQL. You can connect to MySQL in an encrypted manner. MySQL data streams by default are unencrypted, but you can connect as an encrypted user. Now, the problem is that a user isn't necessarily encrypted. You can't just say MySQL be encrypted, right? Like you can with Apache. You can be like, Apache, run on HTTPS and run on port 443, and here's all the security certificates and everything, and go. You can't do that with MySQL. MySQL itself does not run encrypted versus unencrypted. You have connections that you can use SSL with any connection, with any user. You can use it. You can require a user to have to use it, which can be useful. So you might say, okay, I'm in the cloud, I'm worried about this. I want to make my replication user have to use SSL. And the reason for this is because when you log into MySQL, you want to make sure that you're able to log into MySQL. You never want to have a problem where there's something wrong with your security certificate and now you can't log into MySQL with any user. So that's why they do it that way, even though it's a little weird because you can't just like all of a sudden just turn on encryption for everyone. Well, you can because everything's a table in MySQL, but you have to be a little careful about that. So with the operating system, you have to worry about authentication. Are there other installed programs that are running on this system? And if they break into that, what else can you do? Like you might say, well, I have a small application. I don't want the network latency, so I have the database and the application server on the same system. That sounds great, and it's really great for performance. But if somebody breaks into your app server, can they access your data? Now, MySQL does the right thing with regards to permissions on its files and logs, and it does the right thing with regard to having a MySQL user. It doesn't use like the nobody user or anything like that. So hopefully they need to actually get root on your box, and once they get root on your box, right, game's over. So you have to worry about who can authenticate in, who can get past the firewall, what else is on the system. This is pretty much basic for kind of any application. So like I said, MySQL does the right thing with regards to having a server user called MySQL. The files and logs are all good permissions. The max they have is group readable. Very little is world readable, although the configuration file, which is usually an etc my.cnf, that sometimes is world readable, so you want to be careful about that. Passwords on command line. If you type MySQL-u shiri-p password on one, in a terminal window somewhere, and somebody else is on the machine and does a PS, they're going to see MySQL-u shiri-pxxx. Pretty cool. MySQL does the right thing, and it's been doing that for at least since version 4 or something. If not 4.0, it could have been 3.23. But so it's really good about that. Make sure. But if you do that, by the way, it's still going to be in your bash history. So again, know your trade-offs, know your risks. You might say, well, if they can get into my account, I've got passwordless sudo, so game over anyway, right? Root on the box. So it's okay that it's in my bash history. What we do at Mozilla is we have the root itself has a configuration file that has the password in it. Because again, if you're already root on the box, game over. And we have password in sudo, and it has to be a good password, and that's how it works. And we also have, we don't have stupid passwords. We have things I can't even remember. It's 16-digit letters, numbers, all mixed up. No mnemonics or anything, and every single cluster we have has different passwords. So it's very randomized. It's not something that I even know the passwords to. I just log in as root. Well, I sudo when I'm logged in. So I become root, and then I type MySQL, and magically I'm in. And so you should have office policies or a runbook. And I say this because Sometimes you're going to break those policies, right? Sometimes you just need to get something up and running, or maybe you have a development server and you have a slave user and the username is slave and the password is slave, but it's on your development system, so it doesn't matter. Maybe, you know, all production systems have to have encrypted users. Great. Except for like root at localhost, right, which you don't want encrypted in case there's any problems. So make sure that you have these policies. And the reason you want to make sure you have these policies is that if somebody comes to you and says, I can't believe we got hacked, it's your fault, you can point to the policy and say, everybody agreed to this policy, right? Have your security team obviously agree to it back when we did it. So I was within policy, we're fine, you know, it's a CYA technique, right? Covering your ass. So you want to be careful. Securing your application. So you want to make sure that how your application is secure. If anyone can just, you know, hack into your application and break into it, then, you know, they can hack in as your admin user or something like that. You want to be careful about that. So how can you do that? Authentication. If anybody logs into your application, you know, you can separate out. I used to work for a huge dating site, the biggest online gay dating site. It's called manhunt.net, and we actually ended up having an administrative server that we put on a different web server. And so we would load balance the slaves, and read queries would go to like any one of 10 slaves, and then we had this 11th slave, and that was just for the administrative use. And people could read or write to that one. It wasn't a slave, it was its own thing, but that way it never affected, the administrative stuff never affected the users, but you also get that separation, right? That if you went to the regular site and tried to log in with an admin thing, it wouldn't work. You had to go to the admin site. So that was actually a double win. We got, you know, better performance for the users because if there was reporting or whatever, it happened on the admin stuff, and also you know, it was a little more secure. And then the third benefit we got actually was when we would end up doing maintenance on the site, we take the whole site down. When we brought up the site, we brought up the admin interface first. So if like there was some code that just did not work, we saw it on the admin interface first, and then no users logged in, and, you know, because everyone was trying to log in even though we told them there was maintenance. Configuration files, again, my.cnf in MySQL might be world readable. You shouldn't have any passwords or anything like that in there. And again, if they're already on the machine, you know, that's probably not so great either. And you do have to be careful about SQL injection. And we'll talk more about SQL injection later too. So, who has access to MySQL? Now I call this talk Beyond MySQL ACLs, ACL being Access Control List, which is just your list of this user from this host with this password can look at these tables and these columns. But how do you find that out? Well, there's a great toolkit out there called the Percona Toolkit, put out by a company by Percona, who is amazing at naming things. They just have the most creative names. So their Percona Toolkit, all the tools start with PT dash. So PT show grants shows you all the grants. Now, if you want to see the grants of a user, what you usually have to do is, let's say I know that there's user Shiri. Okay, now a user in MySQL is actually a conglomeration of the user and the host, right? So it's not Shiri isn't a user, Shiri at localhost is a user, and Shiri at 127.0.0.1 is a different user, and Shiri at 10.1.1.7 is a different user. They can have different passwords, they can have different grants. I don't recommend it. I've certainly had problems when we were, you know, moving data centers where we had a password was changed from the old password, but it was only changed to like one user. So the other users hadn't been changed their password. It was only this one user because it was the only one that was used. And now, since we were coming through like a different load balancer, another one was used, and they were like, "How come when we moved, everything changed?" And like nothing changed on the box. But what changed was they were coming as a different user. So I do not recommend having different passwords for the same username, you know, with different hosts. So if you actually wanted to see that, you'd have to say, well, I don't know which hosts the username Shiri is on, so I'll just, you know, do a select statement and get like, select host where user from MySQL.user where user equals Shiri. Then you get the hosts, and then if there's 3. Or let's say 2, you know, if there's 127.0.0.1 and localhost, you have to say show grants for Shiri at localhost, show grants for Shiri at 127.0.0.1. Not bad when you have 2, when you have 100 or 200, it can get a little crazy. So PT show grants is awesome because you run PT show grants, it gives you everything. I keep moving around and the sound from this is, I'm sorry about that. So it's great because you get all of the grants if you run PT show grants as the root MySQL user. And now a word about the root MySQL user, I probably have this on the slide later, there's nothing special about it. The name is not special, there's no user ID. It's not like Linux's root where user ID 0 or 1 or whatever it is special. Nothing special about it. It has the super user bit, that's what's special about it. So if you want to delete that user and make a user called admin or super or awesome or whatever, you can do that. So PT show grants shows you all the grants. Pretty cool. When we were changing data centers, we had to change the grants, and so what I would do is I would do a PT show grants. I would cat that into a file. I would open the file, and I would just do a global search and replace on the old load balancers to the new load balancers, and then import the file again. Because you can import grants 100 times, doesn't matter, it's not going to overwrite anything. But then I got the new grants, so that worked out really well. One trick that you can do so you can run queries, select user host password SSL type from mysql.user. Well, the user is the username, the host is the host. The password is a hash of the password. There are 2 different hashes that MySQL uses. A long time ago, there was a 16 character hash. Now there's a 41 character hash. I think it's MD5 or MD5-like. It's not MD5. It's MySQL's own algorithm. I don't know what it is, but it's not MD5. It's not SHA-1. It's not anything like that. But if you are using the old passwords and they don't start with star and they're only 16 characters long, you might want to think about using the more secure 41 character passwords. You can also, if you just do select user host password SSL type from MySQL.user, you'll get all the users because there's no filter on it, there's no where clause. SSL type will usually be blank. When it's blank, it means you're not required to use SSL, but you can. It could actually also be required, or you can have a specific SSL type required, like you can actually require an X509 certificate. For example, if you just, well, I'll get into this a little later, but if you just say that it's required, they just need encryption. It could be an expired certificate, it doesn't matter, right? Because it's not a web server, right? It doesn't matter if it's expired or not, right? It's just there. So you can actually say it has to be from a certain certificate authority, or it has to be from a certain kind of certificate. But for the most part, you can also just say just any kind of encryption. As long as the bad guys can't see it, that's what I want. You can also say where super privilege equals yes. Now what that means is that's pretty much a root user. And that's huge because when you do that, you can actually, there's a lot you can do with super. So one of the things that you can do is you can shut down MySQL. That would be poor, right? If somebody could just shut down MySQL. But you might say, well, who cares? It's the application user. The application user just comes from the web server. They're never going to log into the machine. So another problem is the test database is anything that starts with test or test underscore is the test database, and anyone can write to that. So that's the anonymous user. If you're in the super privilege, if the database is marked as read-only, you can write to it. So you don't want to give too many people that ability, certainly not your application, because what you really want is if your application is trying to write to the slave server, to the read-only server, that they get an error, that you don't want them to actually be able to write. And the third thing is if max connections is reached. So MySQL has a parameter called max connections. It's like Apache's max connections. If you get, let's say I think it's 151 by default, because I think Apache's max clients is 150 by default. So if you get to 151 and you have the 152nd one tries to connect, it will say, sorry, can't connect. It'll say max connections reached or whatever. The good thing about MySQL is that max connections is not actually the number of max connections. You actually get max connections plus 1. Why? Well, what are you going to do if you reach max connections? How do you debug it? You can't log into MySQL to debug it. Well, you can with a super user. So that's a very good reason why you don't want to make your application user a super user, because if something happens and the connections are going crazy and you gave your application that super privilege, then what's going to happen is it's going to grab that last connection, that 152nd connection, to say, okay, and then you don't have a debug. And what are you going to do? You can restart MySQL. Well, hopefully you log in fast enough before all the connections are taken up again to debug it. So that can be a problem. Where user equals blank, I started talking about this a second ago, and I switched tracks because it wasn't about the super user. So I was talking about the test database. Anyone can write to it. So the blank user is actually called the anonymous user. The username isn't blank, it's anything. right? So if my login name on Linux is Shiri, or I do MySQL-U username, I can put any username in there, and let's say the password is blank, which is by default in MySQL when you start it up, when you install it fresh. That means there's no password, and I can actually access the test database. Now you might say, well, who cares? Well, it's not just the test database, the one called test that's already there. It's anything beginning with test underscore. So we've actually had some, I've actually had some people come to me and say like, hey, how come I can see support.mozilla.com's test database? I can see test underscore support, and support could see test underscore addons.mozilla.org. Like, how come I can see that? It's like, well, because it's called test underscore. Everyone can see it. Everyone can see it. Everyone can write to it. They can drop tables. They can add tables. They could start stuffing data into it. They could just start inserting rows, making tables, inserting rows. And what happens is they can actually just fill up your disk. When MySQL's disk fills up, interesting thing, actually nothing interesting happens. MySQL sits there because it's like, well, I'm trying to write to a log file. So it writes to a log file first because it does double write buffering. So it will, before it writes the data to the disk, it'll actually write it to a log to say, hey, if it crashes before now, make sure you write this to the disk. And it will say, oh, no, disk is full, I can't write to that log. Okay, well, wait. How about now? No, still full? Oh, okay, I'll wait. So you basically can't do anything. Everything hangs. You end up getting more and more connections till you reach max connections, and things are bad. So someone who can like log in as the anonymous user, they can take your system down. Not so good. So usually you want to get rid of this anonymous user. I don't know why they still have it in there, but they do. Where is the access from? So I was talking about host. Now in MySQL, MySQL uses SQL-based wildcards, which are % for a multi-character wildcard and underscore for a single character wildcard. So you might have something like, you might see something like Shiri at %. That's from anywhere. Now here's something really cool about MySQL that I didn't even know until I came to Mozilla, because most places they'll be like, %.company.com. We'll just, everybody from the company can just access it, not a problem, but nobody outside of the company can access it. And yes, IP addresses and host names can be spoofed, but just because somebody can break your car window doesn't mean you don't lock your doors, right? Okay. This is my little analogy is like having a website is like parking your car at the mall. Right? If you leave your windows open, if you leave the door open, you can lock the doors, but if you leave the door open, it doesn't really matter, right? The door is locked, but the door's open. If you leave the windows down, if you lock your doors and the windows are up, but you have an expensive piece of equipment in the back, somebody's going to try to get that, right? If you're just a regular kind of site, nobody has any vendettas against you, you're probably fine. You're trying not to be the car that has the doors unlocked, right? If you're the government or a bank, now you're a Porsche, right? Somebody's going to try to break into you because they want you. So otherwise, you're just you're a Toyota Corolla. Nobody really cares. It's great. So where's the access from? So MySQL has this cool thing. It actually does a 5-way handshake. And the first thing it does when you connect. The first thing it does is say, okay, you've got a username at a host. It checks the host against all of its hosts. And if there is not a possibility of anybody coming from that host, you actually get a TCP connection refusal. And I found out this out the hard way, because what I was doing with my network guys, because they are actually all guys in the network team, I would say, oh, we need this network port open. And I can tell because I'm doing a telnet to port 3306 and I can't reach it. And then there was one time where they were like, nope, NetFlow's open. And I was like, but I can't reach it with TCP. And they were like, well, try with Netcat. And lo and behold, Netcat worked. And the problem was that I was coming from a host that wasn't allowed to connect to MySQL, so MySQL was refusing the TCP connection. Pretty cool. So it's a good reason to keep your accesses as tight as possible, because MySQL just won't even let you try. Won't let someone even try a username and password if the host doesn't even connect. So try not to use %.company.com. I mean, if you're in the cloud, you kind of have to go with something like 10.0.% or 10.%, unfortunately, because if instances go up and down, the IPs might change. 192.1.168.% should be enough for a company. At Mozilla, we actually do stuff by like going through load balancers. So we only allow the traffic from the load balancer, and the load balancer can be configured to only allow traffic through from certain applications. So from support only to the support database, from add-ons only to the add-ons database. So we have a huge amount of control over that, and that's useful. And it's not as much of a pain as you might think it would be, because we actually use the underscore. So for instance, if our load balancers are 192.168.1.100 and 1.101, we can just do 1.10 underscore. And then it'll be 100, 101, 102, 103, all the way up to 109. Those are all allowed, but that's at least a smaller block. And doing like 10 underscore is a whole lot less painful than doing 100 and 101, right? It's fewer entries, but it's still not kind of opening it up too much. So again, it's risk assessment. How much is too much when you're opening it up? So granting access. This is a huge amount of information. You can find it on the manual page, but I wanted to show you this because I wanted to show you the scope of what the ACLs can actually do. So most people don't even know that MySQL has this level of capabilities in the ACL. They think it's just username, password, and like database or something. What database can you use? But there's privilege types, so insert, update, delete, drop, create, making triggers. All of those are configurable on an individual user level. You can say that someone can insert into a table that they can't even read. Pretty cool, right? You can actually grant privileges on columns. So let's say you have a credit card table, but people want to do metrics on it, but you don't want them to see the credit card numbers, which of course you've encrypted, but you still don't want them to see the encrypted ones. So you can give them select access on only certain fields of the table if you really want. This helps a lot because the alternative is doing something like making a view where you only select some of the rows, and that can lead to performance issues. So you can grant different privilege types on different columns in the same grant statement. On object type, table name, database name, a routine name. So you have a lot of flexibility. Unfortunately here, MySQL uses star as a wildcard. So you can actually say it's database.tablename. So you can say on table name, on database.tablename. So if you have a database called Mozilla, it could be mozilla.star. That'd be every table in the Mozilla database. You could say star.star, that's for every database. So if you want somebody to have read on every database, you would say grant select on star.star to the user at host. So again, I said user here is actually user at host. We talked about host names and also about usernames and how you don't want to have the same username itself and different hosts with different passwords and grants, but this is how you do it. And then you can give it a password, identified by password, and this require none. These two lines here, require and cipher, these are all your SSL options. So you can say none is by default, or you can say require SSL. So require SSL is any certificate. Require X509 is an X509, has to be valid. Require cipher, specific cipher, so you can say it has to have a specific cipher. And then you can also say a specific issuer. So if you really wanted to get crazy, you could issue certificates for each person that can connect to the database, and then say that person has to use this certificate, and if they leave the company, you revoke their certificate, and you're done. And you can also have a subject, which is just a comment, and then with option, you can say with grant option. Question?
So with the cert options, does it also honor certificate revocation lists?
Does MySQL honor certificate revocation lists? I don't think so, because it would have to go to the list. So I don't think so.
So it's only just checking for a valid cert?
It's only just checking for a valid cert, correct. Correct. So other ACLs in MySQL, you can have the object access, so who can access things like stored routines and stored functions. So you can actually kind of write almost an API into your database, and then instead of giving people access to the underlying tables, you give them access to the procedures. So instead of saying they're allowed to insert on this table, you give them, they're allowed to run this procedure, and then you specify that the stored procedure actually should run as the definer, not the invoker. Right? Because if it runs as the person who invokes it, that person needs the permissions. But you can actually say run as the definer, and the definer has those privileges, and then it will actually kind of almost have your API into it, which is pretty cool. And you have a very, it's like your reusable code and your modular code, it's just in the database. And it's stored in the database, and so, if you have get set things, you can do that in the database instead of in the code, which is useful because then when you have something like mobile code, You can just have it run the same stored procedures. You don't need to recode it every time. Password policies. I talked about having policies. What are your password policies for MySQL? That's really, really hard to kind of work with, because you have to have some kind of program in the middle to say, okay, you have one letter or one number or whatever. I mean, those aren't so great, and you can talk about that and have huge rants about how those kinds of policies aren't so great. But some companies do have them, and you should think about having them for MySQL as well. MySQL doesn't do roles, so you can't say, okay, there's a DBA role which could do everything, and Shiri is a DBA. But there is a program called Security that does have those, and we'll talk about those in a minute. So where do people have access from? You can actually say that there's only access from localhost. It's called skip networking, and then it doesn't even listen on TCP. So it uses sockets in Unix, and it uses either shared memory or named pipes on Windows. Basically local connections only. So for example, on our backup server, we skip networking. We don't listen on any TCP ports. It's all local socket connections. Now replication can still happen. It can still go out and get from TCP ports. So our backup servers, right, one backup server may back up, a dozen different machines, and basically every instance is running with its own socket and connects to the thing, and we have 10 servers replicating, and then when we want to take a backup, we can do whatever we want to that machine because it's ours. There's no slaves, there's nobody using it. So if we want to shut down MySQL and take a backup, by copying the files, we can do it that way. We can do a cold backup. Access from the firewall, right? Who can get there? I know that firewalls are not a silver bullet, but again, they're your car door locks, right? Who here doesn't lock their car? And if you raise your hand, what's your car? Because we'll go to the party lot and find it. And what you really have to think about is you have to think about who can try to deny of service attack you. Because again, I mean, even if you're like, well, we have the port open to everybody, and MySQL will refuse the port connection if there's no ACL, but the port is open. Well, think about this. Does anyone know how many TCP connections the Linux kernel can have by default? I do. It's 10,240. Active. 10,240. And there's a short queue of pending that it can do. And I know this because we were load testing MySQL. And we were using MySQL cluster, and this was for CBS Sportsline, and this is back in like 2007 or 2008 when they were first doing their March Madness, the NCAA basketball stuff online. And they were like, we need 1 million people to be able to be in this queuing system for watching the game. And so we were like, okay, we'll do it. And we couldn't get more than about 10,000 connections, 10,000 users. So we're like, well, this MySQL cluster thing won't work. So we went to like memory tables or something, and we hit the same connection, and that's when we realized it wasn't MySQL at all. So you have to be careful about who can even, if they can even just throw packets at you and use all your TCP connections, if they can do that fast enough, they can denial of service attack you. So I wouldn't even have the port open to the world, because it's not worth it to have people try to even do that. I mean, it's not that hard to somebody gets sysbench and get a load testing script, and they're done. I already said this, I think. The test database, anyone can access it, even the anonymous user. They can stuff it with data and take your system to full disk, and then it does nothing. And it's any database that starts with test. This slide is here because basically stuffing it with data is causing a denial of service attack. So here are some interesting things you can do, parameters in the MySQL server itself that you can actually prevent. You can do some security things. So for example, local infile equals 0. What that means is you can't use a file local to the client to import. So let's say I want to import a file into my database. It'd be really cool to have it on my laptop, import it into the database, right? That's a great thing for developers to have. They have some data, they need to import it, great. With local infile equals 0, what you're saying is they're not allowed to use something local to their machine. It has to be on the server machine, right? So this is someone that you have to trust enough, right? The only people who can load data in are the people you trust enough to give a login, or so they can get some maybe secure FTP. They can get a file to the server somehow. So that's pretty good. And if somebody does end up hacking it or whatever, they can't load a file in. You can do skip symbolic links. This is kind of here for legacy. I don't think there's really a problem with someone like logging to the machine. You could like symlink a data directory away from the real data directory. I think if they're kind of able to do symlinks on your MySQL directory, they're kind of able to read your MySQL directory, and the bigger problem is that they're in as a user that could do those functions. But it is there if you want to. One of the cool things about grant, the grant statements, is that you can actually say, grant all on star.star to Shiri at localhost, but you can specify max queries per hour. So you can say, okay, the user Shiri can only do 10 queries per hour. Or maybe the user Shiri can only do a certain number of updates per hour. By updates, it means writes. So any write, insert, update, delete, replace, that's lowercase updates. And then max connections per hour. So you could say, okay, they can only connect so many times per hour, or they can only do so many updates, or they can only do so many queries in total, right? Updates and reads. The great part about it is it's pretty cool, right? The problem is that, do you really want it per hour? Do you want it per second? Do you want it per minute? And what happens when you reach it, right? Do you get locked out? You get locked out for the rest of the hour. Well, how long is that? How many queries per hour can someone do? There's really no like per second or per day. Per hour is kind of a weird metric. So, it's there if you want it. I mean, obviously you can do the calculations if you want per second. But there you go. So who changes the ACLs, right? Who's allowed to grant permissions on these things, right? Where are you auditing this? It's kind of important, right? And when do they happen? When was the last time you changed your MySQL database passwords when a developer left? Who might know those passwords? Right? Who wants to go tell their boss that? By the way, John left 6 months ago. We never really changed those. Yeah, you don't want to. Who here actually wants to go change those passwords? Yeah, nobody wants to because you're like, I don't know what's going to break, dude. There could be like cron jobs or there could be something. I don't want to break anything, so I'm not going to change the password. It's something to think about. And what I will say is, give yourself a downtime window, change the password, see what breaks, fix that, document it, because you should know what is connecting to your systems. So I mentioned Security a little earlier. Security is written by Darren Kasser. He's a community member of the MySQL community, very well respected. You can do things like create and drop roles. Roles are not necessarily what you think they are. Roles are permissions. So for example, here we're creating a role for select. So that's like a read permission. So I called it read role. So then you can create a user with that role. Like for example, you can call grant privilege. So you grant John at machine.domain.com the read role on the employees database with all tables. And there's a lot of functionality here that you can actually do with that. Security has reserved usernames, so you can actually say nobody can have the username God if you want. You can block users. In MySQL, you can't actually block users. They're either in the table or they're not. You can't just say, take all this information. We have a contractor that comes once a quarter and does auditing, right? In regular MySQL, what you have to do is you have to say, okay, well, add the user, drop the user, or you'll probably just leave that user. With Security, you can actually block the user. So what it does is a series of functions and procedures and a couple of tables. So what it will do is it'll take it out of the MySQL user table, and it will actually put it into its own table, so that it kind of saves it for later, so that if you want to reinstate the access, you can. You can rename users really easily. In MySQL, some of the updates that you might do to the user table actually take away the grants, which I found out the hard way when we were switching data centers, because I was just doing, update MySQL.user set host equal to whatever, and it worked. And then when I connected, I had no permissions. So I actually had to go the PT show grants route to actually change it that way. You clone users, which is really cool, because you'd be like, there's a new DBA, so just clone Shiri, give that permissions to the new DBA. And reconciliation. Reconciliation is just Security has its own tables, so what happens if you don't use Security to add a user? Well, Security doesn't know about it, so you can reconcile between the two. So they've done a lot of thinking about this. Well, Darren's done a lot of thinking about this. So some more server options that are kind of security related. Bind address. This is really cool. So by default, MySQL listens to TCP port 3306. But what IP does it listen to? Any. Actually, all is the correct. I mean, I know that's kind of what you meant. So if you have 7 different IP addresses, it's listening on port 3306 on all of those IP addresses. What'd you say? Okay, I thought I heard somebody saying something. You can actually bind the address to 1 or more IPs. So if you only want to bind that address to 5 out of the 7 IPs, you can. So if you have some kind of huge host that instead of using virtual hosts, you want to do something where you just have many instances on one machine, you can have them all on port 3306 on different IPs. Skip name resolve. So by default, in MySQL's 5-part handshake, one of the things it does is it does a reverse DNS lookup on a host name. So if you give it, foo.mozilla.com, it'll look up the DNS, get the IP address, and make sure it resolves properly. Which is great because DNS never has a problem and is never slow, right? So here's something that's interesting, and I found out this problem. It was a little scary when I found it. So I would log into MySQL. MySQL was slow, so I was debugging it. So I logged into MySQL, and I was like, okay, what's going on here? Show process list. And all of a sudden, I saw like a bunch of regular users running queries. Okay, fine. And then I saw the scariest thing. I saw unauthenticated user as the username, which is kind of scary, because I'm like, okay, MySQL, why are you allowing unauthenticated users? Like, don't even tell me they're unauthenticated. I don't want to know. But what happens is it was part of that 5-part handshake, so they were connected on TCP, but they weren't authenticated yet. And because DNS was so slow, it was waiting for DNS to resolve. So it was unauthenticated, and it was long enough that I could see it when I did a show process list. This always happens, it's just that it's such a split second when DNS is working. If you never want to bother with that, skip name resolve. And what that does, skips name resolution. What that means is, if you have ACLs that are of the type, foo.company.com is the host, they will be ignored. So you have to use IP addresses. So if you go that route, great, but just make sure that you can't do %.company.com. You have to do 192.168.% or whatever your IP block is for your company. Skip show database, again, this is kind of legacy, like, can they see all the databases, can they not see all the databases? If they're in MySQL, what do you really care about? If they can log in, they're already, they probably can do any test databases anyway, so it's not such a big deal, but bind address is cool, and skip name resolve is used a lot. So, back to thinking overall about security. How does your data flow? Where does it go from and to? If you have the need for encrypted data, passwords, government ID numbers, credit card numbers, where is it encrypted, right? So here's your typical application. I'm on my computer. I type in my credit card to go buy something, okay? It's not encrypted on my computer. It's sent over, hopefully, HTTPS, which kind of encrypts. It still sends it in plain text, but over an encrypted connection. And it gets to the server, and the server, might process the information and do something with it. Maybe it takes the last 4, puts it somewhere, or whatever. And it's probably encrypted. Maybe the code might encrypt it and then put it in the database. Like it might say, okay, here's this number, do an encryption on the number, and then put that encrypted stuff in the database. Or the application might say, insert into, credit card table values, credit card, hash of credit card number, SHA-1 credit card number, MD5 credit card number, right? So that's not encrypted until it's in the database, right? If somebody could steal your logs, they would see the credit card number. So ideally, you'd have some JavaScript, right, that encrypts the number right here. Now, that's not feasible because if you're using a credit card number or an ID number, you might need to verify it, right? So you need to know the plain text number. But you have to think about that. What is the flow of that? What is the risk of doing it, the encryption in the database using MySQL's SHA-1 and not encrypting it until it's in the database, so that all the other points along it, it's unencrypted, even though it might be across an encrypted connection. Maybe you should do a SHA-1 on it in your code first, right? So you have some kind of loop that says, okay, take the credit card and do the processing, and after the processing, we're going to store it in. So do the SHA-1 and then insert with the hashed already there. Where do errors go? You really want to know what's happening wrong with your thing, because if there's something wrong in a security kind of a way, you want to know about it. Do you check those logs? And again, where does your traffic flow? Just in general, from the client to you, to the database, to your backups, to, are your backups off-site? Do you have to worry about the truck, right, getting hit? But there was some incident a while back where a truck of tapes was hit and just sitting there on the side of the road. So, there's only so much you can really account for. Separating administrative apps, I already talked about this a little while. Same data, different interface. You can actually get better reporting. One of the things we struggled with when we did this was, were we going to allow it from a VPN or were we going to allow it from anywhere? Because you have the whole thing of, well, if you allow it from anywhere, it's really easily accessible, but anyone can try to log in. If you only allow it from the corporate VPN, right, somebody has to log into the VPN first, so they can't even access it unless they're on the VPN. And the trade-offs there are, sometimes VPNs don't work. If you're traveling, hotels don't always allow VPNs, although they're getting better. Plain text information. Which of these is good for plain text information? All of the above, yes. No, none of the above. Here's the thing. If you don't encrypt it, they'll have it, right? Anytime anyone's like, oh, we'll email your password back to you, I'm like, I'm not using that site. Or my password is Shiri on that site. Credit card information, identification numbers, just don't store it in plain text. But see, we've got some hashes. So, this password here, star27, CCO, whatever, that's actually the word password. Does anyone know what this bottom one is? Just by looking? No?
Rainbow.
Rainbow? Good. That's a good guess. It's actually penguin. And here's the interesting thing. This is actually one that I had to figure out. Because I was trying to, I don't remember why I was trying to figure out what the password was. I think it was, I know what it was. I did a string, so I was on the database, and there's a user table in the MySQL database, and it's a MyISIM table, so in 5.5 and lower, which is what I was on. So I did strings, user.myd, and I saw all of the usernames and the password hashes. And the only user was like this user and like the root user. And I couldn't get to the root user, so what I did was I took those two hashes from the root user and this other user, and put it into Google. And I Google searched for it, because there are rainbow tables out there. So be careful. Now, I should have guessed because the username for this was penguin. I'm sure it was some, yeah, I should have guessed it. I should have tried it. I did try, I think, password and 1, 2, 3, 4, 5 or something, but yeah, it was penguin. I was so embarrassed when I was like, but I was grateful, actually, that I could figure it out, because I wouldn't have been able to figure it out if not for the hash tables on Google. The last time I did this presentation a month or so ago, it wasn't even a month ago, it was a couple weeks ago, I tried to do a demo and show them that, and apparently those sites have been taken off, but I'm sure they'll come back up. But if you do a Google search for this hash, you'll actually get my presentation. So there you go. SQL injection. So there's a good read up on SQL injection at that URL. I'll leave you to peruse that at your own time. But here's a stupid SQL injection. Let's say this is how you get to authenticate. You get account star from users, where username equals whatever the person put in this username, and password equals whatever the username put in this password. And if the count's greater than 0, log in, right? It's a bad example, but I'm giving you the idea here. There might be something you'll nitpick on this slide too. And if the pass is a high, quote, or 1 equals 1, then this is what it becomes, right? Select count from username, wherever the username is, and pass equals high or 1 equals 1. This is great, right? If the password is high, then, okay, you're kind of screwed. But if not, then it goes or 1 equals 1, and guess what? 1 equals 1 is true. So that's the kind of thing you can do in SQL injection. I don't know if you've seen this. But basically, Robert quote, semicolon, Robert quote, parentheses, semicolon, drop table students, semicolon, dash, dash. That's your SQL injection. So basically, they lost their student records, and I hope you've learned to sanitize your database inputs. So here's a real example. This is pretty cool. Somebody pointed out between this once. If you do a curl for the headers on Reddit, you get, HTTP, okay, content type, it sets a cookie, fine, whatever. But then you get the server. Look at this server. Drop table server type. So somewhere there's some software that some bot downloads, right? And they're scanning all these sites to see what server version they're using, because if they're an older server version, they're using Apache 1.3, right? You can hack into it, right? So this is what Reddit does. Thanks, Reddit. And then it gives a date and a connection, whatever. But that's pretty cool. You can do that a little later. Escaping user input, yeah, because there's no route outside. Let's say, we talked about escaping user input. You want to look for semicolon, backslash lowercase g, which is the same as semicolon, backslash uppercase g, which actually does it in vertical output, but basically same as semicolon, quotes, or union. So union allows you to put another SQL query in there. HTML encoding, you want to be careful about that. Why do you want to be careful about that? Well, we actually had this problem at our dating site where somebody would end up, this is not malicious at all, somebody ended up putting in something in their profile where they're like, I want to meet a really cool guy. And then it had bracket, angle bracket, G, close angle bracket. And, and then I like long walks on the beach. When they displayed the profile, all that they saw was, I want to meet a really cool man. They didn't see the G, the grin thing, or I like long walks on the beach, because HTML was trying to figure out what that tag was, didn't know what it was, and just was like, well, I'm not going to display anything after that. And so we were like, oh, that's a problem. Let's see if anyone else has any, HTML in their code. And sure enough, there were 2 people who actually had JavaScript to go open up a new window in the background to go click on their, for pay site, like their click for pay site, right? Which was brilliant. And I was like, you guys are really smart. We're stripping this out now. So that's something you have to worry about. Null characters or car 0, varchar and empty sets. We have to worry about like empty things and buffer overflows and all that stuff. If you validate your input, you will also save yourself time. If you validate an email address, there's an RFC for email addresses. But even if you don't even bother with that, about like what characters can be where, there has to be something at something dot something. There has to at least be at least one character, right? And then an @ sign, and then at least one character and a period and at least one character. Why? Because that's how the domain name has.
You can have a single a hat. You can have a hat, AU. It's valid.
Sure. Okay. So you know that you at the very least need an @ sign, right? And again, you can look at the RFCs. The RFCs say stuff like the email address domain name can't have an underscore in it. So pour all those. Oh yeah.
Underscores are allowed.
I'm sorry.
It's an arbitrary binary string. If you're doing anything other than an arbitrary binary string, you're violating the RFC.
That's not the problem we had when we went with XIM, which went to the RFC for mail hosts, not for email addresses, for mail hosts. Mail hosts can't have an underscore in it.
They're allowed underscores now as well.
But they didn't used to be. Anyway, the point is you can go to the RFC, but you know that there is a template that you have to fill out to get an email address, whatever that template is. So if you validate that, then it saves you time later, because if somebody just puts in the word me for your email address, that's not a valid email address. You're going to try to send email to it, it's not going to work.
And you should then send them an email.
No, you shouldn't let them fill out that form if they didn't send out an email properly. The point is, if you validate your input, you're going to save yourself a little bit of time. Now, you don't know if they put me@me.com, it might not be a valid email address, but at least you're doing a little bit. Worry about your character set. In MySQL, UTF-8 could be 3 or 4 bytes per character. Your input field might be 50 characters, but your length in your MySQL table might be 50 bytes. So you have to be careful about that. And the other thing I will say is there's plenty of libraries to help you. Don't reinvent the wheel. You can use prepared statements in MySQL. So if you do something like this, prepare statement 1, you put question marks in it. It actually takes care of all of the SQL injection and won't let you do anything bad, which is awesome. So you have to use these, the @ variables or user variables. So you say, set @A equals to whatever the user put, set @B equals to whatever the user put, and then you execute the statement and you don't have to worry about any of that. The problem with prepared statements is that prepared statements in MySQL aren't cached. So if, say, you're not using persistent connections, you're just connecting to MySQL, running the statement, and disconnecting, which is what a lot of connections do, it's not cached at all. So what happens is you're doing extra overhead on that statement because you're preparing it, and then never using that cache. So you're actually doing double the work because you prepare it, then execute it. So it would be less work to just execute it. So there's no benefit there. And for a while, it was whenever, when I was in a consulting company, whenever anyone had something slow, we were like, are you using prepared statements? And the answer was yes. Trusting get or post. So get in a URL really easily and really simply is anything like after a question mark. So if you've seen sites where it's like, oh, shiri.com/ question mark ID equals 5. You only want to trust, so that's a get. Those are get variables up there. Post variables are similar, except instead of showing up in the URL, they're actually hidden in MySQL. So now you have to worry about things like cross-site scripting, cross-site request forgery, where you might have a site that's not your site that sends information to your site. And so it might use those get variables or post variables, but it didn't come from the page before that you assumed. It came from a different place. You have to worry about cookies, even with valid session IDs, right? Because there can be session hijacking. Now, I'm not saying don't use cookies, but again, these are trade-offs and risks you have to worry about. Registered globals goes off in PHP. I think anyone who's dealt with PHP knows about this. But what registered globals does is it makes a get variable into a post variable or post variable. Yeah, get variable into a post variable. So you might say, well, you're only looking at post variables, but then somebody could actually put it in the URL and do question mark ID equals whatever, and that would actually be used. Stored code. You can use stored procedures or functions. I talked about that before, about kind of making an API into your database so that you can give permissions to the stored procedures and nothing else. You can also use views to give people a window into your code. With the grant statements, you can actually give people columns. With a view, you could actually give columns and restrict rows as well. So you can say that a company can only see their data. Maybe you have a bunch of companies and there's a bunch of the data and it's all in the same table. So instead of only restricting the columns with views, you can restrict rows as well. If you use MySQL events are pretty cool. There's some conditional language and flow logic in them, if statements, case statements. And if you use them instead of cron, the cool part is, so let's say you have something like you have, a site and you want to show how many people are logged in at a time. If you try to do a count star from the sessions table every time, you're going to have problems because once you get like 1 million people on the site, you're just constantly counting that sessions table, nothing else can get done. So you might say, well, every 5 minutes we'll run a cron script, it will log in and do a count star from the sessions table and put it into this other table, and this other table is cached. The problem with that is when you run it from cron, you have to log in and use a password. If you use an event, it's inside MySQL already, so you don't have to use a password. So this is the concept of if you don't store it, they can't steal it, right? If somebody can get on your system and they can see your cron job for some reason, then they might be able to see it. So auditing and monitoring, we talked a lot about prevention, but it's only one part of security. You can actually do auditing, so it's reviewing and assessing security. You can actually buy appliances to do this for you. McAfee, so MySQL actually has an auditing plugin interface. And if you buy, from Oracle's Enterprise, whatever, you can get their version of it. But McAfee actually has a free, open source thing on GitHub where you can download that. And monitoring is alerting of security issues. That's kind of difficult to do. You might be scanning the error logs to see if somebody's trying to connect, the general log, if somebody's trying to connect and can't do that. Monitoring on security issues is difficult. That's more of what the kind of appliances do. You can use the general log to see all login attempts, even if they're not successful. That adds like a 1 to 2% overhead and huge log files because the general log logs everything. You can also lock out accounts with max connect errors. This is pretty cool. What you can say, so by default max connect errors is 10. Now what it means is if you try to connect 10 times like in a row unsuccessfully, MySQL will lock out your password. Now, that's in a row unsuccessfully, so if you get past 2 or 3 times and then you log in successfully the 4th time, the counter's reset. The problem is that it's not like a forever thing. If I log in today and then tomorrow I log in again, the counter's already reset. It's kind of within a short period of time. But I have seen it with things like when you change the monitoring user's password. It's also global, so if I log out 10 times and my boss wants to be able to log in 15 times, you can't do that. It's the same number. The other thing is, in order to get your account back, to unlock it, you have to do a flush hosts. And the problem with that is it's global as well. So if 2 people are locked, you can't just unlock 1 person. So it's kind of a cool idea, but again, not implemented so well. So I like to say play hard to get. If you don't store it, they can't use it. MySQL events, instead of using a cron or task scheduler, don't put anything in plain text that shouldn't be in plain text. And don't even store it if you don't need it. If you have processed credit card payments and they're one-offs, you don't need to store the credit card number. Maybe a hash of it, maybe just the last 4 digits. If you're doing recurring transactions, you probably have to store the credit card number because every month you have to decrypt it, charge it again, and encrypt it again. But don't store it if you don't need it. There are authentication plugins in MySQL 5.5. You can actually do PAM authentication and Windows authentication. There are enterprise plugins. Those are for pay. I think there's also some open source versions out now. I haven't updated this slide. I forget. I think it's one of the SkySQL MariaDB or Percona has put out an enterprise plugin, PAM authentication. So you can do LDAP authentication to the database, which is pretty cool. So create the policies, right? There'll be exceptions, but it's a good idea to have the policies so that nobody blames you for following policy. And that's it. If there's any questions or comments, let me know. That's a little old. I wrote a book a couple years ago. It's MySQL Administrator's Bible. I think it's pretty good. I also have CDs of the RSQL podcast. So if you do work with MySQL, I think it's a really great podcast because I do it. You can find it on iTunes or FeedBurner if you use those. And any other questions or comments? Yeah.
Hang on.
Oh, wait for the microphone.
Just a sort of thing that I felt was missing. There's a lot of access control stuff that's good, and it's all good to have it, but assume failure. Have a plan to recover when they do get in and they corrupt your database and you notice a week later that they've mucked around with all of your prices or whatever.
Right, and that's where you want the auditing in, right? Because you need to detect what has happened. And there's, that's also disaster recovery, what happens when you do that. So that's a whole, you're right, that's a whole nother session. So yeah, definitely try, and that's where you have to know when it happened too, because, if someone comes in and doesn't corrupt it, right, they just read it, how do you know? The general log does log in all attempts, or you could have some kind of proxy that logs that stuff, which is what those appliances do. They're basically a proxy. So it's scary, and a lot of people don't do more than the ACLs, and they really should. All right, thank you. I'll be around all week, so if you have any questions, let me know.